scientists seek clues to birth of cancer. Cancer research, scientists seek clues to how disease is born. British and American scientists are teaming up to search for the earliest signs of cancer in a bid to detect and treat the disease before it emerges. They plan to give birth to cancer in the lab to see exactly what it looks like on day one. It is just one of the research priorities of the new International Alliance for Cancer Early Detection. Working together on early detection of cancer will mean patients benefiting more quickly, it says. Cancer Research UK has teamed up with the universities of Cambridge, Manchester, University College London, and Stanford and Oregon in the US, to share ideas, technology and expertise in this area. Together, the scientists are aiming to develop less invasive tests, such as blood, breath and urine tests, for monitoring high-risk patients. Improve imaging techniques for detecting cancer early and look for virtually undetectable signs of the disease. But they admit this is like looking for a needle in a haystack, and could be 30 years off. The fundamental problem is that we never get to see a cancer being born in a human being, says Dr. David Crosby, head of early detection research at Cancer Research UK. By the time it's found, it's already established. Scientists say research on early detection has been small-scale and disconnected, lacking the power of trials in big populations of people. Dr. Crosby said their collaboration would induce a sea change in our health systems, shifting it from expensive firefighting of late-stage disease to being able to intervene at its earliest point and deliver. Figures show that 98% of breast cancer patients live for 5 years or more if the disease is diagnosed at stage 1, the earliest stage, compared to just 26% at stage 4, the most advanced stage. But, at present, only around 44% of breast cancer patients are diagnosed at the earliest stage. In the UK, screening programs exist for breast, bowel and cervical cancers when people reach a particular age. However, there are currently no reliable screening tools for other cancers, such as pancreas, liver, lung and prostate, which means survival rates are often much lower. Professor Mark Emberton, from UCL, said the growth of imaging, such as MRI, was a silent revolution, which could replace needles, used in biopsies, in the diagnosis of prostate cancer. Imaging only sees the aggressive cells, it overlooks the stuff you don't want to find and addresses overdiagnosis, he said, but he warned it was expensive and took time, and was not ready for prime time yet. More accurate hyperpolarized MRI scans and photoacoustics, where laser light is delivered to the tumor, creating sound waves which are analyzed to produce images, are the next advances being tested in imaging. Professor Emberton said the next goal was to see which cancers lent themselves to this type of imaging. At the University of Cambridge, Professor Rebecca Fitzgerald is developing an advanced endoscope to detect precancerous lesions in the food pipe and colon. She said early detection hadn't been given the attention it deserved, and some tests for cancer could be very simple and inexpensive. Professor Fitzgerald said she looked forward to working with international colleagues to take ideas all the way from the bench to the bedside. Cancer Research UK is investing £40 million in the International Alliance for Cancer Early Detection over the next 5 years, with $20 million being contributed by Canary Center at Stanford University and the OHS Unite Cancer Institute in Oregon.